Welcome to the solutions to the Regents Physics Kinematics problem set, problems number 22 through 34. Let's get started right here with 32. A batter hits a pop-up straight over home plate at an initial velocity of 20 meters per second. The ball is caught by the catcher at the same height that it was hit. At what velocity does the ball land in the catcher's mitt? Neglect air resistance. As shown in this diagram, if the ball has an initial velocity of 20 meters per second upward, and it goes straight up, then at the peak of flight, where it changes direction, it will have to stop, and therefore its velocity will become 0 meters per second. Then it will come straight back down. In the meantime, the acceleration due to gravity has remained constant because the force due to gravity is constant on the ball. So the speed that it has initially becomes 0 at the top, and then that 0 speed becomes the final velocity at the bottom, which is identical to its initial velocity of 20 meters per second. So the short answer of it is the ball will have the same speed when it returns to the mitt, as long as it's caught at the same height from which it was hit. For 33, in baseball, a fastball takes about a half of a second to reach the plate. Assuming that a pitch is thrown horizontally, compare the distance the ball falls in the first quarter second with the distance the ball falls in the second quarter second. Diagram here, here's the ball that's thrown horizontally, and the dotted line I'm tracing at the moment shows the path of the ball that it takes in half a second. Since it's accelerating due to gravity vertically, it will have fallen a short distance in the first quarter second and then a greater distance in the second quarter second, since it's accelerating downward. So the dy value for the first half of the trip will be less than the dy value for the second half of the trip. 34. You throw a stone horizontally from the edge of a cliff. In a second throw, you gave it more speed. A, how would the time it took to hit the ground be affected? Neglect air resistance. And B, how would the increased speed affect the distance from the edge of the cliff to where the stone hit the ground? I've drawn a little diagram here. Here's your stone thrown horizontally from the edge of a cliff and the path that it takes. And what you learned from your video lesson for a projectile fired horizontally is that it is the same as being dropped. So it would not matter how fast you throw the stone horizontally, that this stone, no matter how fast you throw it horizontally, is going to be the same as it being dropped, which is no initial velocity horizontally. So the time to hit the ground would not be affected. It would be the same no matter how fast you threw it or drop it. B, how would the increased speed affect the distance from the edge of the cliff? So if we consider that to be from here over to this spot right here, that would be called the range of the projectile. And that's the horizontal distance. And clearly, if we increase the horizontal speed, we would increase the horizontal distance. So it would go further away from the base of the cliff the faster we threw it horizontally. That'll do it on problems 32 through 34. More to come tomorrow as we go over problems 35 and 36 in class.